and this is our phase 2 presentation, which is the last one for SCST1223, probability statistic and data analysis. Today we are presenting an inference statistical analysis of social media usage in Malaysia. So we have 6 sections to cover. First of all is dataset overview. Annie will start, and then Hazirah will cover the hypothesis testing, and then Aeman takes the correlation analysis, Luqman simple linear regression, and I will be demonstrating the chi-square test and ANOVA for an extension. Right, let us get started.
Okay, so our data was collected through a Google Forms survey, and we ended up with 76 valid responses from Malaysian residents. Looking at the sample, the mean age is 20.4 years, which makes sense because most of our respondents are university students. We studied 5 social media platforms in total. The 2 key variables we are working with throughout this whole analysis are daily usage frequency and content rating. Both of these are measured on a scale of 1 to 5. Usage frequency is our predictor variable, or in other words, X, and content rating is our response variable, or in other words, Y. Those two will keep coming up in every test we run. Platform and peak usage time are the categorical variables we use later in the chi-square test and ANOVA.
Alright, thank you, Amy. So, our first inferential test is one sample t-test. So, the question that we are trying to answer here is, can we actually say that Malaysian social media users are generally satisfied with the content they see? So, we set the null hypothesis as a mean rating of 4.0, which we define as just average satisfaction. So, the alternative hypothesis is that the true mean is greater than 4.0, so this is one tail test. So, with 79 respondents, we get a sample mean of 4.28 and a standard deviation of 0.67. And that gives us a t-statistic of 3.982. Okay, now the important part is the p-value is 0.00215, which is way below our alpha of 0.05. So we reject the null hypothesis. There's a strong statistical evidence that users are rating content significantly above average. So this suggests that social media recommendation algorithms are actually working quite well at serving content that people enjoy.
Okay, thank you, Hazirah. Moving on to the correlation analysis, we want to know whether there is a linear relationship between how often someone uses social media and how highly they rate the content. We use Pearson correlation and we got R equals to 0.218. There is a weak positive correlation. What it means in plain terms is that people who use social media more often do trend rate content slightly higher, but their relationship is not very strong. The p-value is 0.053, which is just barely above our significant level of 0.05. The 95% confidence intervals goes from negative 0.003 to positive 0.423, and notice it just barely crosses 0. So we fail to reject the null hypothesis. This is what we call borderline result. The trend is there and it is going in the right directions, but it is not statistically conclusive with our current sample size of 79. If we had more respondents, that would very likely become significant.
Okay, so following on from the correlation, we now build a simple linear regression model. The equation is content rating equals 3.642 plus 0.150 times usage frequency. What this tells us practically is that increase in usage frequency, we would expect the content rating to go up by about 0.15 points. So, heavier users do predict slightly higher ratings. However, looking at the results, the p-value for the slope is 0.053, still just above 0.05, and the R squared is only 0.0476. That means usage frequency alone only explains about 4.76% of the variation in content rating. That is quite low. So we fail to reject the null hypothesis. The model is technically not statistically significant at the 0.05 level. Usage frequency is a weak predictor on its own. Other things like the platform someone uses, the type of content, their age, or demographics are probably much better at explaining why people rate content the way they do.
So thank you so much, Luqman. So for the next slide is the chi-square test. So for this optional test, I am covering two, which is this one is the chi-square test of independence. And the question here is whether the platform someone uses is related to when they use it most during the day. So the null hypothesis is the platform and peak usage time are independent of each other. And then the alternative is they are associated, meaning the platform and peak time are associated. So if you look at the contingency table, something jumps out straight away. Evening dominates every single platform. TikTok has 27 users, Instagram has 13, and even the smaller platforms like YouTube and Thread show the same pattern. Nobody really scrolls in the morning, so running the test, the chi-square test statistics is 9.41 with 12 degrees of freedom. So we use Monte Carlo simulation because some expected cell counts were small, and then the p-value came out at 0.667, which is well above 0.05. And then the result is we fail to reject the null hypothesis. Conclusion, that platform and peak time are statistically independent. So the real takeaway here is not just statistical, but it makes also logical sense because Malaysian university students are in class or busy during the day. So everyone ends up scrolling in the evening regardless of which app they prefer. And then the last but not least, which is the one-way ANOVA. This is an extension. This is still on me for this one. Our second optional test is the one-way ANOVA. So the question here is, do different social media platforms deliver different levels of content satisfaction, or is the mean rating basically the same across all 5 platforms? So the null hypothesis is all 5 platforms means are equal. And then the alternative, at least one platform mean is different. So looking at the bar chart here, you can already see that the means are not identical. YouTube users rate content highest at 4 point, and then the X users rate lowest at only 3.50. That is more than a 1 point gap. And TikTok, Instagram, and Thread fall somewhere in between. So when we run the ANOVA, the F statistics is 2.508. The critical value at alpha is 0.05, is 2.49. Those are extremely close. So the p-value is 0.049, just under 0.05. So we barely reject the null hypothesis. Now there is an important caveat I need to mention. This technically uses one-way ANOVA with unequal sample size. Because we have 41 TikTok users but only 3 X users. That variant is actually beyond our syllabus scope, but we included it as analytical extension with the help of Dr. Kwan because it was the most natural way to analyze our dataset. So the result is statistically significant but should be read carefully given how small the YouTube, Thread, and X groups are. Okay, I think I will let Aini to wrap up.
So, alright, to wrap everything up, here are our 5 key findings.
So 1. Algorithm satisfied. The t-test gives us strong evidence that users rate content significantly above average, with a p-value of 0.000215. Social media algorithms are doing their job.
For number 2, there is a weak positive trend between usage frequency and satisfaction. But both the correlation and regression just miss significant at 0.05. A larger sample would likely confirm this.
Number 3, usage frequency alone is a weak predictor. R squared is only 4.76%. So other factors like platform, content type, and user demographics explain most of the variation.
Okay, fourth, is scrolling is universal. Platform and peak usage time are independent. Everyone scrolls in the evening regardless of which app they use. And then lastly, 5, from our ANOVA extension, platform does appear to matter because YouTube users are more satisfied and then the X users least. So the result is borderline significant but should be interpreted carefully due to the unequal group sizes.
So overall, the data tells us that Malaysian social media users are genuinely satisfied with their content experience and that platform algorithms are broadly effective. So thank you for listening, and that's all from us.